Welcome everyone to another BGCSE past paper review. Today we're reviewing a chemistry paper. We're reviewing a paper 1 from 2021. Please remember when you're starting this exam, as a matter of fact, before you start the exam, write your school number, write the candidate number, also write your surname and the initials. Again, read through all instructions carefully before you start the examination. For example, here they give you that you can use a calculator. That's very important. Also read through the other instructions in details, because on this paper they give you an instruction that about the volume of gases at room temperature and pressure, all right, to be 24,000 centimeters cube, which is the same thing as 24 dm cube. Also, they give in standard temperature and pressure as well to be 22,400 centimeters cube, which is the same thing as 22.4 dm cube. All right. So once you go through instructions, please make sure you understand them well. If you do not understand them, please ask the examiner to explain before you start the examination. Also, they typically give you a periodic table, which is very nice of them because you can use the periodic table to guide you in terms of answering certain questions as well. All right. So that's very important there. So let's deal with question number 1. And the question number 1 is a forensic scientist wishes to separate the dyes in a sample of red ink found at a crime scene. Which technique would she use? Now, if you look at it quick, carefully, you're going to realize that the answer is right there. Option A, chromatography. Chromatography is used to separate colors, right? Can't be crystallization, fractional distillation, and simple distillation. No, we know those for sure that you separate, especially fractional distillation to separate liquids with similar boiling points. We know that, all right, for sure. And for simple distillation, we use to separate like liquids from a solution, right? So example, we separate water from a salt solution and so on. All right, and crystallization, we can use crystallization to form crystals out of a solution. For example, copper sulfate crystals out of a copper solution, right? All right, so yeah. All right, so question number 2. It said water was tested and it was determined that the melting point here is 273 Kelvin. And just to make a note that 273 Kelvin is the same thing as 0 degrees Celsius. All right, so 273 Kelvin is the same thing as 0 degrees Celsius. This is the melting point here of water. All right, and so what they ask us here now is which property is demonstrated by this test. So you cannot use temperature to test if something is odorless. That's actually used in smell. All right. If it is pure, yes, you can use the test if it's pure, because substance melt at a particular pure substance, as a matter of fact, melt or boil at a specific temperature, right? So the pureness of a substance can be tested by using temperature. So if a melting point or boiling point should increase or decrease, then you know that, hey, there must be some impurities in it, right? Tasteless is by taste, of course, and if it's a universal solvent, is a test if multiple amount of different substances will dissolve within the substance. All right, so yeah, option B is straightforward. All right, now for question number 3, it said in a titration, the titrant as the unknown volume. So make sure I like this. Is the titrant as the unknown volume, right? And the substance being identified as a known volume. So let's just say the substance being identified. I want to just point out something here, right? It said which apparatus is used to measure the substance to be identified, and which apparatus is used to measure the volume of the titrant. All right, in a typical titration situation, right? The titrant is of a known concentration, okay? And the titrant is what we call this standard solution. It is used to test the concentration of another substance or another solution, right? So typically, again, titrant is standard solution. The substance that is being identified is what we call the analyte, okay, or the reagent. All right, and so we want to analyze it. That's where the word analyte comes from. And the titrant or the titrator, which is the same thing, is what we use to determine the concentration of another substance. All right, so I want you to follow me now carefully. Again, if you have a known volume is a standard volume, right? And in this case, we're saying that what is being tested for as a set volume. So if we use a Buret, this is a Buret, a matter of fact. All right, let me just kind of make a note of these instruments. So this is what they call a Buret, okay? Now, a Buret has varying volume. If you, as a matter of fact, you know this graduated, right? I mean, it's kind of a dull on this diagram, but yeah, it is a graduated piece of equipment that give a varying volume. So I must put varying volume right here, right? Varying volume. All right. And now we have here now on the other side is a pipette. And a pipette is what is used to measure a set volume or fixed volume. So this here you have a fixed volume is being measured with a pipette, right? So a matter of fact, you can even say a standard volume. And honestly, I thought that when I was in school doing chemistry at the first time, I really thought that pipette only has 25 ml. All right, because in our labs we only have pipettes with 25 ml, and every time we measure the substance or or the titrant, we always measure 25 ml. So honestly thought, and matter of fact, most of the exams back in those days, you'll notice the pipette say 25 ml. So I honestly thought when I was in school that pipette were only 25 ml. All right, but again, pipette can have different standard volume or different fixed volume. For example, a pipette could have a 5 ml, which is uncommon. The most common one is 25 really. It could have 10 ml, it could have 25 ml, 15 ml, or even 30 ml. So we have different ml or different set volume of pipettes. Now a conical flask, if it is graduated, it can use to measure varying volume as well, right? So a conical flask could use to measure varying volume, all right, or a set volume. All right, so here now, our best answer here. All right, so since we know the volume of so notice this, the substance being tested for, the known volume is there. So we can call it a standard volume. So what is best to use to measure a standard volume is definitely a pipette. And to test the unknown volume, we're going to use a Buret. That is the best thing to use. So option D here, right, for me is the best option. All right. To test the set volume, use a pipette. To test the unknown volume, use a Buret. However, though, in the examination, they also gave B as an option because the conical flask can also be used to measure a set volume of a solution as well, right? Just to point that out as well. All right. All right, so let's jump into the next question. But I said option D would be my first choice. Again, they also gave option B as another option. So you have two options there. All right. And understand the logics behind that, which makes sense because the conical flask can also use to measure a set volume of solution, right? Now, just one thing before I even go back to the question number 4, just to point out one thing again. Remember that the Buret is used to measure or to deliver, let me see, deliver varying volume until the end point of the reaction is reached. And normally in a titration, you use an indicator to indicate the end point of that reaction, all right? Just to give you that piece of information there. All right, so let's go into question number 4 now. And the question number 4 says, which of the following best describes what happens to particles as a solid melts? So what you need to remember that we're moving from solid to liquid, right? And just to remember, like your cooling curve or your heating curve, that just as when substance changes state, there's no change in temperature. So for example, ice, as ice melts, the liquid that came from the ice is the same temperature as the ice, all right? But for this to happen though, you must apply heat, all right? And as you increase in temperature or you apply heat to something, what you're actually providing is energy. That energy is known as kinetic energy. So kinetic energy, or the theory, or kinetic energy theory actually states that now that temperature, right, is equivalent to the kinetic energy, which means as you apply heat or there's an increase in temperature, the particles should gain kinetic energy and move much faster. And that's why if we move from solid to liquid to gas, the particles end up moving faster as they apply heat. If you go the reverse option now, or the reverse way, and remove heat, then what happens? The particles eventually move what? Slower. Okay? So kinetic energy is proportional to what? Temperature. All right, so solid to liquid, because this is melting taking place, then the particles will move faster, which means they gain kinetic energy. So it's either between A and B, right? However, now, moving from solid to liquid, then without a doubt, you know that the particles will move further away from each other. They move much loosely, all right? Or they move freely over each other. So therefore, B will have to be your option, all right? Now, let's go to question number 5 now. So question number 5 now, you say, which row of a table describes an atom of two isotopes of the same element? Key point. Once you're talking about the same elements, all right, or isotopes of the same element, the fact that they say same element, then therefore meaning must have the same proton number, because remember now, the proton number or the number of protons is what describe or define an atom. Okay, that's very important. So if you are the same element, you must have the same proton. Same proton give rise to the same atomic number. Okay, so it's between C and D. Now, what makes a difference in isotopes? Isotopes have different mass number, and the difference in mass number is because of a difference in the number of what? Neutrons, as in option D now. All right, because remember, proton plus neutrons give you your mass number. So if the mass number going to be different, is because of difference in number of neutrons. So yeah, option D is the correct statement right there. All right, so question 6 is a molten aluminum oxide decomposes by electrolysis. In this process, aluminum ions become aluminum atoms, and oxygen ions form oxygen atoms. How does aluminum ion form an aluminum atom? So let's look at this now carefully. There's something we need to know first. That atoms, they are electrically neutral, right? So I'm going to draw the atom here for aluminum. Aluminum atom, is electrically neutral. For an element to form an ion, it either gains or loses electrons. Metals lose electrons to form cations, which are positive ions, right? So follow this now carefully. For aluminum to form a cation, it will lose 3 electrons. So let's put 3 electrons there. 3 electrons is taken away. And while it loses 3 electrons, it will become a positively charged ion, which is called a cation. So it becomes Al3+. How we know there's 3 electrons going to be will be missing or taken away from aluminum is simple because aluminum is in group 3. So the valence amount of electrons there is 3 valence electrons. You lose all those 3 valence electrons to form a 3+ ion. All right, so the amount of electrons that you lost, that's the amount of positive you will become. All right, so the number of protons are now greater than the number of what? Electrons. So let's use this as a product. So Al, all right, loses 3 electrons to form Al3+. If you have the ion and you want to form back the atom, you must recombine these two, all right, to form your atom. And your atom again is electrically neutral. So if you add the 3 positive, the 3 negative to the 3 positive, you get 0 charge. So moving from the atom, you loses 3 electrons and form 3 positive. If you recombine them, you will get your electrically neutral atom. All right, so this is an easy way to kind of know exactly what is moving. Or you move from atom to ion and from ion back into atom. All right, so if you notice, my arrows are indicating what is happening here. The plus sign could read 2 things. The aluminum formed these 2 products, which is 3 electrons plus the aluminum positive ion. And if you recombine them, or is a reversible, if you think about the reversible way of reaction, then you can recombine them to form your Al. All right, so our option here now for question number 6 is that the aluminum will gain 3 electrons. So A will be our answer. Matter of fact, you should read in aluminum ion gains 3 electrons. That's what it means. But actually, up here stated though, the aluminum ion form an aluminum atom. How it does that is because the aluminum ion gains 3 electrons. All right. Now let's go to the next question. And number 7 now said, what is the correct formula for the compound formed between potassium and oxygen? And just a quick little revision here that potassium is in group 1, so you know there's a positive 1, All right, just remember that. So it's a positive 1. Potassium is a positive 1 from group 1. All group 1 atom elements form positive 1. So let's just put K plus up here, positive 1. And oxygen is from group 6, so all group 6 element will form 2 negative ions, so it's going to be 2 negative. All right, in the basic form, right? And so remember now, to make the compound, all you need to do is to crisscross these charges. So now crisscross that charge. So the oxygen will need only 1, but you need 2 potassium. All right, so we're going to put it like that. So just to crisscross them. So 1 oxygen, as in positive 1, 2 negative will give you 2 of the potassium. So yeah, number 7 here is B is our correct answer. Okay, for number 7. All right, so K2O. All right. All right, so let's jump to the next question. Now, question number 8. We're going to roll through this a little bit technically fast. All right, let's see how fast as we can go with this one now. Number 8. And so what is the number of moles of 38.70 grams of copper 2 sulfate? And to do this, the first thing to do is to find the mass number, because number of moles is equal to the mass given over the relative molecular mass of the compound, right? So to find the mass number, the RMM of this, what you need to find is the mass number of copper. The mass number of copper is 64, so let's put 64 right here. All right, 64 plus sulfur, and sulfur is 32. All right, so we're going to put 32 right there. Plus oxygen, and oxygen is 16, but is multiplied by 4 because you have 4 atoms of oxygen. And so 16 times 4 there is going to be 64 as well. So 64 plus 32 plus 64. And we get a total there of 160. Okay? So this is 160. So what we're going to say now is that we're going to have our mass given, which is 38.7. So we're going to say 38.7 divided by 160. And that equivalent to 0.24. Yeah. 0.24. And so 0.24 is the number of moles of copper 2 sulfate of 38.7 grams copper 2 sulfate. All right, cool. All right, so number 9 is what is the molar mass of iron 3 sulfate? And this is the formula right here. So to find the mass of this, it's still formally relative molecular mass, right? So the molar mass, same thing as relative molecular mass. And so iron will be the mass number. If you look at the periodic table, this is 56, right? So 56 times 2. So let's say 56 times 2. All right, 56 times 2. So 56 times 2 is 112. Okay, so 56 times 2. Yeah, because iron is 2, so it gives a 112. And then for the sulfur now, the sulfur is here going to be 32 times 3. So 32 times 3, that is 96. All right, so this is going to be 96. Just with a plus sign right here, going to add up all of these. And then we have our oxygen, and oxygen will be 4 oxygen times 3. So it's going to be 16 times 12, and 16 times 12, because remember now it's 3 times 4, right? For oxygen. Oxygen is 16, so 16 times 12. What we get there is 192. Okay, 192. All right, so if we add up all of these now, what we get as a result is 400. Yeah, 400. Yep. So our answer there will be D. Okay, D is our answer right here. All right, for number 10. All right, which we are 1/5 to the end. All right, it said, what is the basicity of ethanoic acid? All right, so let me just quickly explain this. All right, when I talk about the basicity of an acid, right, or a substance, it is actually telling you the number of hydrogen atoms in that acid that can be replaced by a base. All right, so let me just write that down, and so we understand exactly what that means. When we talk about basicity, talking about is the number of hydrogen ions. All right, or atoms. If you want to say atoms, is fine. Atoms or ion really don't matter. All right, atoms are ion in an acid that can be replaced by a base. All right, in an acid in an acid that can be replaced by a base. All right, so there's a little some. Let me give you an example so you can understand this a little bit more, right? So, for example, here now, if you have an acid like say HCl, HCl is only one hydrogen, right? So the basicity of HCl is 1 because it only has one hydrogen to give off anyhow. For sulfuric acid, for example, H2SO4, right? For H2SO4, it has 2 hydrogen atoms to give away. So guess what? The basicity of sulfuric acid is actually 2, okay? Because these 2 hydrogen atoms can be replaced with the base. Because remember now, if you're going to form a reaction, for example, like a substitution reaction, the H2 will be used to form water. And in this case, the H will be used to form water. And so they have a chloride salt and you have a sulfate salt if you use the sulfur, right? So these can be replaced by the base, just to make sure, note that. Or to neutralize the acid, the hydrogen will be given off. In other words, acid will dissipate a certain number of hydrogen atoms. All right, so hydrochloric acid dissipate only 1 hydrogen ion. Sulfuric acid will dissipate 2 hydrogen ions. All right, so that's how we determine the basicity. Now, for ethanoic acid, all right, what I can do is to give you the formula for ethanoic acid. But ethanoic acid is an organic acid. An organic acid has this as the functional group COOH. Okay, so in the functional group of the acid, you only have one hydrogen. Okay, so the formula for ethanoic acid, a matter of fact, is C3, all right, C3COOH. And remember, the COOH part is what giving you the acidic property, because that's the functional group of acid. So in this, we only have one single hydrogen ion, okay? Only one. So let me see if I could highlight that. Yeah, only this one alone will be dissipated within the solution or will be replaced in that reaction. So yeah, ethanoic acid only has 1, all right? So number 10 is 1. All right, cool. Number 11 is which gas is produced when magnesium metal reacts with dilute hydrochloric acid. So think about this now, right? We're looking at the gas of this form. As a matter of fact, you should know the rule by now that metals react with acid to form hydrogen gas and a salt, right? So we know they're going to form hydrogen gas. So we just can, hydrogen gas is what's going to form, and the salt will be formed. All right, so if magnesium react with hydrochloric acid, we're going to form hydrogen gas and magnesium chloride, right? Okay. All right, number 12. Number 12. Is what are the products formed when copper 2 oxide reacts with sulfuric acid? All right, and so here now, if you think about it, you can do the reaction, and you can understand it by looking at the reaction. So let's say copper 2 sulfate. So copper 2 sulfate is going to be Cu. Copper 2 oxide is going to be CuO, right? And if you write this with sulfuric acid, so now say plus sulfuric acid, just go show you what you can do to kind of figure it out. And sulfuric acid is H2SO4. And so you know for sure now that the copper will replace the H2. Remember, we talk about that just now, talk about the basicity of the acid. So you form copper sulfate and water. So the H2 will react with the oxygen from the copper oxide to form water. And then the copper will react with the SO4 to form the copper sulfate, right? So we're sure they're going to have copper sulfate and water as our answer here. Copper sulfate and water. So D is the option. Okay, so again, let me just put this one here. That the copper will replace the hydrogen and react with the sulfate to form copper sulfate. The H2 react with the water, with the oxygen to form water. Yeah, so that's our answer there, D. All right, so we call it that. All right, 13. It said to which class of oxide does aluminum oxide and zinc oxide belong? All right, I want to quickly just mention something right here too. I guess I could just explain a few things. Metal oxides, right? Metal oxides, they form either one of two things. They form either basic oxides or they form amphoteric oxides. Now, the simpler metals generally will form, or the more reactive metals will form the more basic oxides. But aluminum and zinc, for example, you know, they are less reactive when it comes on to reacting with acids and so on. So they will form what they call amphoteric oxide. So these are amphoteric oxide. So that's right off the bat right there. And just to make mention, let me just write that down real quick here. So we have metallic oxide. So let's call metal oxide. So we have metal oxide. And metal oxides, as I said, they form two types of oxides. And so they either can be described as basic or amphoteric. So either basic, and I must give you what basic is. So basic or amphoteric. Amphoteric. I think I'm doing something wrong here. Amphoteric. All right, so yes. So either or either, right? And let me just tell what basic oxides are. And basic oxides, they react with acids to form salt. That's what basic acid oxides do. They react with acids to form salt. But amphoteric now, they react with both acids or base. Okay, they can react with both acids or base. Now, non-metal oxide, as I was talking about oxide, let's talk about the non-metal oxides. It's not a part of this question really, but just to give you that information. So non-metal or oxides of non-metal, you may want to say that. So non-metal oxides now, they are either of two things. They're either acidic oxide or neutral oxide, right? So this will be neutral. And if you look at the word, you can actually explain it, you know, because amphoteric, you know, if you remember in biology, we talk about amphibian. Amphibian can live in both water and land. So the same thing with amphoteric oxides, they can react with base or alkaline, right? But the basic oxides now can only react with acids, right? And they react with acid to form salt. Now for non-metal oxides now, is it acidic or neutral? So if for acidic oxides now, they react with water to form acids, right? So if you think about, again, in a biology lesson, when we talk about acid rain, right? To form acid rain, you have things like carbon dioxide. And that carbon dioxide is a non-metallic oxide, right? You may have your sulfur dioxide, your sulfur trioxide, the nitrogen dioxide, the nitrogen oxides. They will form acid rain, right? And so they are acidic oxides. You also have neutral oxides from non-metals, right? And these neutral oxides, they react with none of the acids or the base. So they do not react with the acid or base. That's why they are neutral, right? They do not take part in the reaction at all with acid or base. All right, just to mention that. All right. So being neutral, you'd choose none of the sides. All right. All right, number 14. Is a chemist measures 23.26 grams of calcium hydroxide. All right, and this year, just to point this out, that this must be this is an aqueous solution. Matter of fact, calcium hydroxide is a aqueous solution. What is the concentration of this substance in mole per dm cube? So, all right. Oh wow, we have no volume here. Okay, concentration is the mole over volume, right? All right, but what you can assume then, since there is no volume, because normally you have a volume given, all right, but we have a mass. We can find the mole for sure, and so we don't have a volume to find in concentration. But what I'm going to do, since this is an aqueous solution, I'm going to assume now, just to make an assumption here, just to point this out, so I'm going to tell you what assumption I'm going to make right here. We're going to assume that water is a solvent. Then again, water is a solvent, is aqueous, right? And since water is a solvent, we know that 1 gram of water is equal to 1 centimeters cube of water, right? So we're going to assume now that 1 gram of water, 1 G of water equals to 1 centimeters cube. Okay? All right, let me just put that there, just to mention that water is the solvent. So what we're going to do is to find the mole here. And to find the mole, let's find the RMM first. So calcium here is going to be 40. All right, so calcium is 40. All right, so calcium is 40. All right, so we're going to have 40. Oxygen going to be 16 times 2. And that's going to be 32. So it's going to be 40 plus 32. All right, 32 is for the oxygen. And then we're going to have for the hydrogen, we're going to have 1 times 2, which is 2. So we're going to plus 2 here, right? So all of this together will give us 74. Yeah, 74. All right. And so to find the mole now, we're going to divide, to find the number of moles. What we're going to do is to divide the mass given, which is 23.26, divided by 74, and that equivalent to 0. This equivalent to 0.31. Yeah, so this based on calculating 0.31. All right, not 2, 0.31. And so the answer here is going to be B, again, with the assumption that we account for the volume of the solution, right? For example, the standard solution in, for example, 1,000 centimeters cube, which is 1 dm cube. All right, so we could just make that assumption right there. All right. All right, so that is mole per volume or per dm cube of the substance. All right, so number 15, right? For number 15, it states that which salt is prepared by precipitation. And just by looking through the list, I'm looking for a salt that is insoluble. Because insoluble salt will form by precipitation, and barium sulfate is something you need to know, that barium sulfate is insoluble in water, right? All right, so barium sulfate is indeed our answer. Matter of fact, to make barium sulfate in the lab, you need barium hydroxide and sulfuric acid to form barium sulfate. And then once acid neutralizes the base, you're going to get an insoluble salt, which is barium sulfate salt, right? So you're going to use sulfuric acid and barium hydroxide to form this salt. All right? All right, so number 16, running through that real quick. It said which acid has a pH range of 0 to 1, and this is a strong acid. All right, acetic acid is an organic acid. It's a weak acid. Carbonic acid is in between, so it's kind of moderately strong. All right, citric acid is an organic acid as well, so it's a weak acid. And so sulfuric acid is the strongest acid right here. All right, it's really strong acid in nature, so it is the answer. All right, so that's one, don't need too much explanation there. 17 is which ion is found in all acids. And all acids, matter of fact, to become an acid, you must dissipate H plus ions in a solution, right? So without no thinking, H plus ions all belong to all acids. We talk about that now when you talk about the basicity of acids. So yeah, we know H plus ions. Now for 18, it's a sodium hydrogen carbonate, right? Which is baking soda, is used to make bread rise in hot oven. It said which row of a table gives the name of the gas produced and the reagent used to test for this gas. All right, so we know to make gas bread rise is carbon dioxide doing that, all right? So the baking soda will produce carbon dioxide. If you notice again, at the end of it is CO3. So the CO3 part will form into CO2, right? When a chemical reaction takes place. All right, so matter of fact, to neutralize, because a neutralization reaction is going to form salt, water, and carbon dioxide, right? So carbonates, when we react on the acidic condition, form salt, water, and carbon dioxide. So carbon dioxide is the answer, and you use lime water to test for carbon dioxide. So there's not much talking and thinking about this one. All right, so we're good with that. All right, so let's go into the next one now. Question number 19. It said Dennis was given an aqueous compound, call it X, right? And he added aqueous sodium hydroxide to this, and a white precipitate formed, is a which was dissolved in excess aqueous sodium hydroxide. Which cation was present? All right, and it talk about, first thing you need to point out right here, right, is that you form a white precipitate. Okay, you use aqueous sodium hydrochloric acid, sodium hydroxide. Use sodium hydroxide. We want to figure this out. So we use sodium hydroxide. All right, so that means you're looking for the cation, and what you're looking for here is a solution as an hydroxide to be insoluble. All right, and so right here now, let me just think about this, because we have here if you have calcium hydroxide is soluble. All right, and calcium hydroxide as an aqueous solution is actually colorless. Until you pass carbon dioxide through it, then yes, it become cloudy, which is calcium hydroxide going to be our lime water, all right? So if you pass now, which is copper hydroxide is insoluble, but copper hydroxide is not going to be white, all right? Not going to be white at all. And copper normally form greenish colorist substances, just to mention that. Like copper sulfate will be blue, but copper salt, some copper salt will be greenish. So anywhere between greenish to bluish. Calcium is definitely white, but calcium is going to be soluble. In this case, iron will form a soluble white. Is white in nature, is a white substance, but definitely going to be soluble. But the insoluble one is going to be zinc. So zinc is the insoluble one. All right, so let's just call it a day with that. All right, so the product of, so if you think about these in the form of hydroxide, because hydroxide must be added to all of these, just based on the reaction, sodium hydroxide. So all of this, because all of these will replace the sodium and to form like calcium hydroxide, copper hydroxide, iron hydroxide, and zinc hydroxide. That's the bottom line in the reaction here, right? They will all form hydroxides. All right, so you think about the hydroxide that is insoluble, and that one is zinc. All right, 20. It said acidified aqueous silver nitrate, right, is added to a solution, and a white precipitate is produced. Which ion is present in this solution? Again, is acidified silver nitrate, right? And for the fact this acidified silver nitrate, what we're going to look here for now is the silver. Let me see. No, barium cannot form. Barium will form the nitrate. So this will be barium nitrate. So barium nitrate will be formed if you react the substance with barium in this case, or that a solution contain barium. So barium can replace silver to form barium nitrate, right? And so we think about barium nitrate is a soluble white substance. Chloride, if you react a substance with chloride, what you're going to form here now is silver chloride. It's called silver, which is an anion, react with a cation, which is silver. So chlorine, I should say, chlorine is an anion, will react with the silver, which is the cation, and form silver chloride. Silver chloride is insoluble or partially soluble substance, and it is white, of course. So that could be an answer right there. Let's look at magnesium. Magnesium, since a metal, it will form with the nitrate. So therefore we got magnesium nitrate. And magnesium nitrate here is a white crystal, and it is soluble in water. All right, the sulfate now. The sulfate will react with the silver. So you have silver sulfate, and silver sulfate is also insoluble as well. But if it's acidic, you may not have this reaction with the sulfate, because if it's acid, let's say using a sulfuric acid, for example, then this sulfate will not be able to react with the acid or with sulfuric acid, for example, right? It cannot replace sulfate. Sulfate can replace sulfate. So the best one here will be chlorine, all right, or the chloride one, because again, both of them are insoluble. A matter of fact, the sodium silver sulfate is more insoluble than even silver chloride, right? All right, just to mention that. I guess this is generally just because of the reaction in the acidified condition. And again, sulfate cannot replace sulfate. If you use a sulfuric acid, for example, it cannot use. All right, there will be no reaction in that case. All right, 21. In some older style food packaging, the following reaction takes place. And it's which type of chemical reaction is occurring in the above equation. And if you look at the equation carefully, you're going to realize that, hey, here you have this addition reaction, as a matter of fact. It is an addition reaction. The oxygen react with iron to form iron 2 oxide, which is rusting. But there's an addition reaction here. But the next best thing here, they give us a minus energy. So they give off this amount of energy, a negative energy, which indicate that it's an exothermic reaction, right? So based on the energy change, it's a negative value, it's an exothermic reaction, just to mention that. Number 22. It's which theory best explains why chemical reaction occur at different rates. So atomic theory, no, it's not indicating about no reaction. Avogadro's theory, no. Collision theory is indeed good. The kinetic theory, as I mentioned earlier in a question, it said that it just referring to the temperature gain, right, is equivalent to the kinetic energy of the particles. Higher kinetic energy, particles move faster, which means they have more energy, and there's also an increase in temperature. So collision theory, which is the correct answer, and collision theory actually states that the rate of reaction is proportional to the number of collisions between molecules of the reactants. So again, as the particles of the reactant collides more and more frequently, then the reaction rate will be much faster. A matter of fact, something cannot react unless they collide. All right, so collision must take place. The particles must bombard each other for a chemical reaction to take place. The more frequent they collide and bombard each other, the faster the rate of chemical reaction. All right. 23. It said use the equation and state which statement is true. So here now you have carbon monoxide reacted with nitrogen dioxide to give you carbon dioxide and nitrogen monoxide. So the big thing happening here now, think about it. Notice number of oxygen. This is going to be a key in this question. Notice you have carbon monoxide turns to carbon dioxide. So carbon monoxide gains oxygen. So this one gain oxygen. So I'm going to put a plus oxygen right here. It does kind of help us remember what to say right here. So you plus an oxygen right here forms CO2, right? So this gain oxygen. The NO2 now lost an oxygen, so we're going to minus oxygen from this. All right, and so you get and you have NO right here. So in terms of the answer, right, it's a carbon monoxide is neither oxidized or reduced. No, that's not true. Okay, gain of oxygen is oxidation. All right, gain of oxygen is oxidation. Loss of oxygen is reduction. Right. Here's a carbon monoxide. Carbon monoxide is reduced. No, it's actually oxidized. All right. And C is a nitrogen dioxide is oxidized. No, it is reduced because loss of oxygen. So you said nitrogen dioxide is reduced to nitrogen monoxide. Yeah, because you form nitrogen monoxide right here. So it is reduced. Loss of oxygen to form NO. So it's reduced to nitrogen monoxide. Yeah, this is the answer for that question. All right. Here now it said 24 it says strips of copper and zinc metals were placed in separate beakers, each containing 0.5 moles per dm cube of silver nitrate solution. The mass of the metal strip and volume of silver nitrate solution were kept constant. All right, so then you keep the mass of these things constant. You put them together. You have the same concentration of the solution here. All right, which is silver nitrate solution. And down here in the axis now, it's after 10 minutes, it was observed that more silver metals was deposited on the zinc metal strip compared to the copper metal. So the zinc has more silver onto it versus the copper. All right. It's a which statement correctly explains the observation. Let's run through this. It's a copper and zinc are equally reactive. No, because one you have more deposit than the other. It's a copper is less reactive than zinc. That seems in it true because you have less deposit on the. All right, so let's just make a little notation right here. That looks good. Copper is more reactive than zinc. That is not true because you have less of the silver on the copper, right? It's a silver nitrate solution more reactive with zinc. All right. So if you look at B and D, if you may think that they say the same thing, because if you think about it carefully, it's a silver nitrate solution is more reactive with zinc. Saying that copper is less reactive than zinc because zinc is where you have more silver silver deposit formed. But if you look at D, these are the correct statement in chemistry at all, Is not correct. The silver nitrate solution, you can't say the silver nitrate solution is more reactive because that don't really work. I'm gonna tell you why. An entire solution do not react. All right, follow me now carefully. Understand what I'm saying. A entire solution do not react. No, an entire solution definitely does not react at all. How reaction takes place is that the bonds must be broken to form new bonds, right? So it's not the solution that is actually reacting, but the ions within the solution. So the silver ion, that is a bond breaking, you break up the bonds in silver nitrate to get you your silver, all right, and silver will be a +1. And your nitrate ion, which is NO3 minus. So is the nitrate ion will react and the silver ion will react. So again, it is not the entire solution. So it sounds the same way as B, but it's not. Chemically, it is not true. The statement is not true chemically. Because again, the silver nitrate solution is not what is reacting, but the ions within the solution. As a matter of fact, too, if you look at the strips, the strip were placed into it, so you're testing the reactivity of the strips. And so definitely we're going to say copper is less reactive than zinc, because zinc you have more deposit compared to copper. All right, so definitely B is the best option. D can play trick on your mind. If you look at it seriously, it can play trick on your mind, but the entire solution does not react. It is the ions within the solution, because guess what? Zinc can replace the silver, okay? And that's what is important. Look, remember the metallic, the reactive, the series of metals, right? All right, so that's what you need to think about as well. All right, so B is the answer for that question. All right, so let's jump to the next question. All right, so this question have no number. It's a diagram shows a cell used in the electrolysis of brine, and brine is salt solution, just to mention that. It's a use the diagram to answer question 25 to 27. Okay, the question is below, the questions are below here. All right, so we'll jump into questions. Question number 25 is which particles conduct electricity in the wire and electrolyte. So electrolyte can be molten in our solution, and so if it's molten in our solution, electrolytes will contain ions. Remember, ions again, because remember now, electrolyte will decompose, right? Electrolyte will decompose to give out ions, and ions will move to the electrode depending on the charges. So cations move towards the cathode, so the positive ions move towards the negative electrode. And in the wires now, electrons are moving, so it is A is the best answer right here, all right, and not D, okay? All right, so A is the answer for question number 5. Iron metals or the wires, electrons flow through wires, and the electrolytes will produce our ions when they are decomposing by electricity. For 26, is hydrogen gas is released as a product of electrolysis. Which test shows the presence of hydrogen? And hydrogen will give a popping sound in the presence of a glowing splint. So bleach's litmus paper is incorrect. Matter of fact, B is the correct one. So explode with a squeaky pop. Relates a glowing splint. That is actually oxygen does that. A is actually for test for chlorine. Turns lime water milk is carbon dioxide. So chlorine is for A. C is for oxygen. And oxygen is for C, I should say. And carbon dioxide is for D. Okay. All right. So just to note those tests. All right. So you need to know those tests. 27. It says which of the following substances will not conduct electricity if placed in a cell? So if placed in a cell, it will not conduct electricity. When I mean a cell, I mean a battery. All right. You can put acids in battery for sure, and you can put salts within batteries, and they will conduct electricity because salts will give off the ions needed. And just think about electrolyte as well. So molten potassium iodide would be good. Ethenic acid will be good, and yeah, but the one is not. Oh Lord, let me take these out. They said which is not. All right, so the not one here is pure water. So the pure water will not able to produce those ions readily for electric current to flow in a battery or a cell. All right. Actually, will dilute the substance in it and make them weaker, and less ions will flow. A matter of fact, right? So you have less current. All right. So use the following list of salts to answer question 20 to 30. I'm going to try to speed up a little bit more now. So you have ammonium nitrate, you have lead 2 chloride, you have potassium hydrogen carbonate, you have lithium iodide. And they said which salt is insoluble in water? And the salt that is insoluble in water right here off the bat is lead 2 chloride. Okay, so lead 2 chloride is insoluble in water. So 28 is actually B. All right, so for 30, so which salt is used in fertilizer? And fertilizer contain nitrates. All right, so fertilizer contain nitrates. So ammonium nitrates are good in fertilizers. And remember, ammonium nitrates will cause excess, well, not excess growth, but cause growth in plants because the nitrate is used to make proteins, right? Just some bio knowledge right there. 30 is which salt gives a lilac flame test. So lilac is like a pale purple, pale violet type of color. So the salt that gives off that purplish color in the flame test is potassium hydrogen carbonate. So yeah, so that one is the answer, which is C. Yeah, that's C. All right, 31. It says which of the following is a correct property of salt? Is a salt a covalent bond? No, salts are generally, well, salt could be covalent bond, but not always, you know. All right, but generally salts are ionic compounds. All right, just to make mention of that. All right, so you have organic salts. All right, so yeah, salts are generally, as we mentioned here, that they're ionic substances. So, like example, talking about our magnesium sulfate, all right, or sodium chloride, which is an ionic compound. All right, they said do not conduct electricity when molten or aqueous. That's not true. They are good conductors, especially in molten and aqueous forms. Low melting point, they actually have high melting point and boiling point. But most of them are soluble in water. Definitely so. Most is soluble in water, definitely. All right, so it depends on the type of salt. But most salts are soluble in water, of course. Most. All right. All right, next question. Question 32. We're almost there. It's a piece of calcium is added to distilled water in a container. What is the expected pH of the suspension form? And if you add calcium in water, what you're going to form is calcium hydroxide. Okay? So adding calcium in water, you form calcium hydroxide. All right, so forming calcium hydroxide, you know that's a base, right? Calcium hydroxide is a base and it's a relatively strong base. A strong base. Hydroxides really form relatively strong base. So here we're gonna have D, which is relatively strong, not excessively strong, but yeah, moderate thereabout. So 32 will be will be D. All right. All right, 33 is a bauxite is an ore found in earth, in the earth. Which element is extracted from this ore? And everybody know that bauxite forms aluminum. So this is a straightforward direct answer. We can just move from that. All right. 34. So let's see if we could speed up things a little bit now. All right. 34 is which of the following is not a raw material used in the extraction of iron? What is not used in the extraction of iron? And it's a air. Of course, we need air. It's a carbon monoxide. Carbon monoxide is not used. Carbon monoxide is actually poisonous to human beings. All right. It depletes the amount of oxygen in your blood. So if you should take in carbon monoxide in your body, it's going to cause it not to absorb the hemoglobin, not to absorb oxygen. And so it's a poison substance in human beings. So it's not really used, matter of fact, it's not used, period, in the extraction of iron. All right, but hematite is used, limestone is used. So all of those are used. So go back to the extraction of iron, then yeah, you'll see all of this they are needed. All right, so for next set of questions now, it said use the letters. There was a letter choice, the letter choices to answer question 35 to 37. A letter choice may be used once, more than once, or none at all. So A, you have alkaline earth metal. B, halogens. And halogens are group 7, right? Noble gas, which is group 8. And the transition elements is which of the letter choices describe each of the following elements? Organ. Organ is a noble gas, right? So noble gas here is going to be C. All right, cool. Next one is iodine. Iodine is in group 7. So iodine is group 7, so is a gas, but is halogen is in group 7. So if I is in group 7, B will be an option right here. All right. Beryllium. Beryllium is from group 2. Okay, beryllium is from group 2, so it's an alkaline earth metal. Group 1 is alkaline metals. Group 2, alkaline earth. So 37 here is A. All right. 38 is which element is the most reactive non-metal? And the most reactive non-metal here is fluorine. Matter of fact, fluorine is the most electronegative element. Most electronegative element, which means it takes on electron to itself much faster than any other non-metal. So it's the most reactive non-metal. All right? It's the most electronegative, which means it is the non-metal that can take on electrons to itself the fastest. All right? Which means it's going to be more reactive than all the others. Now, 39 is which statement describe why manufacturing large quantities of sulfuric acid is economically beneficial. All right, and so A said all the steps in the manufacturing process produce energy rather than requiring energy. That is not true. Some of them require a lot of energy. He said large quantities of sulfur are easily extracted from underground deposit. Not so. They use a lot of energy to do that. Oxygen and water requires for the manufacturing process are naturally available. They're naturally available, yes, but it's not. That's why it's important to produce them economically. Sulfuric acid has a large number of industrial uses. Yep, tons of uses for sulfuric acid. Sulfuric acid is used in fertilizers, right? Or even to make fertilizer. Sulfuric acid is used in detergents. They're used in paints or dyes. They're used to make explosives. sulfuric acid is used to make plastics. There's a number of things you can use sulfuric acid to do. You have a number of use. All right. 40, it said which one of the following represents a molecular formula for ethanol? And ethanol has 2 carbons, because you think about meth, eth, and all alcohols end with OH. So we have only 2 options, which is B, either B or D. Okay. A is chloromethane. It is not alcohol because it must have OH to be an alcohol. C, there is an OH, but there's another thing here. You have actually COOH, which is an acidic substance. So this is ethanoic acid. All right. So it is not alcohol at all. C is not alcohol, even though it ends with OH. But the fact that you have COOH is acidic. So this is ethanoic acid. So ethanol must be 2 carbons. So this one is the answer, C2H5OH. All right. All right. 41, and we almost there. So which one of the following shows homologous series? And homologous series is a number of a group of compounds that vary from each other with a set number of atoms or a set ratio of atoms, right? That's what the homologous series is. So it's a group of atoms or elements or chemical substances that vary from each other by a set ratio or pattern or number of atoms, right? So if we look at option A, right, it's not homologous for the fact that you have an OH right here that make this different from the rest, right, to even talk about. B, matter of fact, just say homologous, they must be the same family as well. Just to point that out, right? They must be the same family. Their general formula is the same. They have the same functional group, just to mention that. So B now is saying that C2H4, they have C3H6, and they have C4H8. If you notice, as it increased by 1 carbon, the number of hydrogen increased by 2. So that is a steady increase of between carbon and hydrogen, right? So yeah, that would be our answer. These are not belonging to the same group at all. No, they're not the same. All right. They're not homologous, in other words. But homologous actually refer to organic compounds too. Just to mention that as well. So even though they're all in the same group, being halogens, and these here at the bottom may be in the same group as group 1, they're not homologous because homologous actually refers to organic substances. All right, so 42, it said which catalyst is used in the contact process? And in the contact process, we use here is vanadium pentoxide. And so D is our option here. And just to make a note that vanadium pentoxide is used to oxidize sulfur dioxide to form sulfur trioxide. So it is used to convert or oxidize, let's say oxidize SO2, all right, into SO3, which is sulfur trioxide, all right? Sulfur trioxide. All right, I remember here in the contact process, the process for contact process is producing sulfuric acid. Just to mention that, right? So your contact process used to produce sulfuric acid, which is H2SO4. All right, and so what will happen here, the vanadium oxide, which is an oxidizing agent, it will use to oxidize, which is sulfur dioxide into sulfur trioxide. And of course, then sulfur trioxide can react with water to form sulfuric acid. Because remember, sulfur trioxide now, again, remember talk about this is an acidic oxide, is a non-metallic oxide. So this is an acidic oxide here because a non-metallic oxide, so it's an acidic oxide. And if you react sulfur trioxide with water, it forms sulfuric acid, right? And then, however, it's not going to be concentrated. It's going to be a little dilute. So you could actually do the process by extracting water and so on, and to make it concentrated and all that. So the go to a number process, not just easy like that, right? So this is the contact process here. All right, so yeah, so vanadium is used to oxidize this to this, then the sulfur trioxide can turn into sulfuric acid. All right, that's the contact process. 43, in 43, it said the experiment shown was set up to investigate the rusting of iron. It said the presence of which substance in this experiment allows rusting to occur. So for rusting, it must have oxygen, it must have moisture. Those two things you must know, right? I don't even know how to explain it any simpler than that. For rusting to take place is a chemical reaction between iron and oxygen, but it must take place in the presence of moisture. So you need water. So oxygens need to oxidize iron. That's what or rust form. Okay. So D will be your option right there. Okay. All right. So D is our option: oxygen and water, which is moisture. All right. So let's jump into the next question now, which is question now 44. And question 44 is said a compound with a formula XF2 has a relative molecular mass of 78. What is element X? All right, no. Two ways to do this, Two ways to do this. Let's do this in two ways. All right, so first and foremost, you can look at some options in it. Well, this organ is not an answer, right? You know it for sure. Organ can't be the answer because organ don't react with anything. It's a noble gas, so we know A is out. But I'm going to show you two ways you could do this. You have what they call back crisscross. Well, I just call it back crisscross. If you want to call it that, that's fine. So back crisscross is actually looking at the compound and reversing the crossway to get back your ions, right? So for me now, iron, fluorine, I'm going to reverse the 2 and bring it up here. All right. So reversing it 2, that means X. All right, let me do it a little bit cleaner so you're going to get exactly what I'm talking about. Let me do it a little bit cleaner. So let's put the X first. Let's put X up here and let's put F. All right, so I'm going to reverse the cross thing. All right, so coming from the F, I put the 2 up top, right? So that's going to be 2. And since X is in front, it is a metal, so it's going to be a positive charge. That is a 2 plus, right? And then the X now is 1, so we're going to take the 1 up here. And since it's on this side is a non-metal, so it's going to be a negative. So fluorine, of course, is in group 7, right? Which is a negative 1. So X is a positive 2, which means it must have a group 2 element, right? So a group 2 element, just to talk about that. So if it's a group 2 element, the only group 2 element there is calcium. So right off the bat, we know that is calcium, right? All right. Hold on a little bit. We're going to look at something else too. Another way to do it is this. There are 2 ways to do this thing. 2 ways. So one way we figured that is calcium already because it's a group 2 element, right? Another way to do this is look at the compound XF2. We do not know the mass number because here they give us the mass number here, all right? F2 with this fluorine, so fluorine is 19 times 2, right? So we're going to say 19 times to get the mass number. Okay, 19 times 2, that's the mass number of fluorine in this case, and it equals to 38. Okay, 19 times 2 is 38. Now, if you take away 38, so if you say 78 now, let me say minus, put the minus sign right here, minus 38, right? 78 minus 38, what do you get as a number right there is 40. Which of these elements has a mass number of 40? Is calcium as a mass number of 40? Organ, technically as a mass number of 40 because 39.9, right? So both of them has mass number of 40. But as I said before, that organ cannot react because of noble gas. So by 2 ways, we realize that our answer here is actually calcium. By doing the back crisscross, or doing the mass number way. All right. So the remaining mass will be for X because if F2 is 38, the remaining mass must be for X. And so calcium is your answer right here. The mass number for platinum is, we've got the periodic table going to be 195, right? So that's definitely not that's out the league. Zirconium, the mass number for that is 91. So that's out the league again. Its atomic number is 40 for sure. All right. So zirconium mass number is 40. Atomic number is 40, but the mass number is not 40, right? All right. So yeah, so B is the answer. Now let's jump to the next question now, 45. So question number 45 now, it reads that which of the following present in water can cause profuse growth of algae. And profuse growth is just saying that excess growth of algae is called eutrophication. And we know that nitrates is what is needed for causing eutrophication. So that right off the bat, because nitrogen-rich compounds is good for plant-like organisms to grow, good for plants as well to grow rapidly. Yeah, make proteins. So definitely nitrates is the answer for that. That's a bio knowledge. Help us with that. 46. It said, which of the following is a substitution reaction? Which is a substitution reaction? We have 4 more questions to do after this. And a substitution reaction, if you look at the first one, is an addition reaction. All right, the first one is an addition reaction. The two H's add up to this, the H's add to this H to give you 6 H's. The second reaction is also addition reaction as well. This one here is a substitution reaction because one of the H will replace by one of the Cl. Yep, so instead, matter of fact, 2. Because here you have H6 and here you have H4 and you have a Cl there, right? So the Cl is being replaced, H replaced by a Cl. So yeah, this is a substitution reaction. All right. For D is a combustion reaction. Ethanol in the presence of oxygen will combust to form carbon dioxide, water, and energy. So we have A and B are addition reaction. C is a substitution reaction, and D is a combustion reaction. All right, so 47 now, and then we are almost there. So 47 is a question 47 to 49 refers to the following organic compounds. Each letter may be used once, more than once, or not at all. So we have ethane, ethanic acid, ethanol, and ethenes. These are all compounds with 2 carbons, right? 2 carbons. All right, so the first thing here now is said that which compound is a saturated compound. Saturated in organic sense, it means that they contain maximum number of hydrogen. As a matter of fact, they belong to the alkane homologous series. So the alkane homologous series, they are saturated, maximum number of hydrogen. And so A is our answer right here. All right, so which compound is found in beverages? And beverages, not all beverages, some beverage, ethanol, rum. That's drinking alcohol, right? So C is our answer for that one, ethanol. All right. Then 49 says which compound is used as a starting material for plastic, and the plastic here is formed by ethylene. I said ethylene, as you notice. Ethene is the starting product. All right. That can be used. So this is going to be D for answer right here. All right. And 50 last question says ammonia was manufactured during World War II to make explosive. Which of these substances can ammonia also be used to manufacture? And ammonium, we talked about ammonium nitrate in a question before, and is used to form fertilizer. So definitely, yeah. So 50 going to form fertilizer, ammonium nitrate fertilizers. All right, so this is the end of the review. So have a great day, and I hope you wish you luck, I should say, in your examination. So stay safe and be blessed. All right, see you soon.